topper. In this video session, you are going to learn about impulse. So what is impulse? In shortest terms, I would say it is just the impact of a force. How much a force can impact. Like you can see here, this is a man pushing a car when he's alone. So he is able to change the momentum. He might be able to give it some velocity, but it will take him a long time, say t1. In the other picture you see, there are three people pushing a car. So they will set up an acceleration or change the velocity of this body in another time interval t2. For sure, your t1, that time interval is going to be much longer than t2 because there is more number of people and hence greater force in the second case. So that means either we can change momentum if a body by a larger force for a short time or by exerting a small force for a long time. So if this force applied is less, the time will be more. So I have a force applied and that is applied for a time t1, and this has to be same as F average into time t2. But okay, I'll remove average because I am talking here of F1 and F2. So the product is same, but this says that if F1 is small, or I would say if F1 is less than F2, then obviously the time taken t1 is greater than t2. So the product remains the same. If force is bigger, the time will be shorter. This can be expressed in terms of change of momentum also, which we have already done in Newton's second law of motion. So where we define that force is equal to the rate of change of momentum. That is how we got that force is equal to rate of change of momentum, because the greater the force, faster the momentum will change. From here, if I take this t up, what does force into time give me? It says it is equal to mv minus mu, which is change in momentum. So this quantity mathematically defines impulse. So in general terms, impulse is impact of force, but mathematically impulse, we denote it as J, is equal to either you can say the product of force and time, or it is equal to the change in momentum. So depending on the question what is given to you, you can use anything, any formula out of these two to determine the impulse. When the force applied is constant, then finding the impulse is not a problem. But what if the force is variable, which generally is in real life? So let's plot a graph. If you look at this is a force versus time graph. The force is constant in this case as it's a horizontal line parallel to time axis. So what if we find the area of this force versus time graph? You get the area of a rectangle, which is giving you the length times breadth, and that is force into time. That means area of a force versus time graph gives you what? That's the impulse. Now the second graph is a variable force. So the first force is increasing and then the force starts decreasing. In this case also, if you find the area of the FT graph, you will get it as half into base into time, half into base into height. So half into base is the time, and F max is the force that acts for that time t. So that also gives you the impulse. So let's have a look at an example based on finding the impulse from a graph. So this is the question, which says the sketch graph shows how the force acting on an object varies with time. So we are given this force, how it is increasing up to 15 Newton in first 5 seconds. Then from 5 to 20 seconds, that force remains constant. And then 20 to 25 seconds, the force again drops to 0. They have given us the mass of the object m is 50 kilograms and its initial speed u was 0. Calculate the final speed of the object. Let's see how to do that. We may be able to find the final speed if we know the final momentum. And we know the initial momentum is 0, but from the impulse we can get the final momentum. So we have been given the force versus time graph, and we know the area under the force versus time graph is equal to what? That is equal to the impulse. So let's find the impulse in this case. So our total impulse here is equal to half into base into height for the first region. Then second region is length times breadth. Third region is again half into base into height. So impulse is half times base, that is 0 to 5 seconds, times height is 15, plus we have half into base into height again for this region. So that's 5 times 15, and plus the area of the rectangle, the height and width, base, they both are 15 and 15. So 15 times 15. So what do we get? We are going to get, so this is the same number, so we can say twice of this. That will make our calculation easier. And plus 15 times 15 is 225. So we have 75 plus 225, which gives me 300 Newton second. That is force into time, Newton second. That's the unit of impulse. Now we want to find the final speed of the object. Impulse has given me a change in the momentum of the object, mv minus mu. Mu was so anyway 0. So basically impulse here is equal to the final momentum mv. So 300 divided by the mass of 50 kg would give me the velocity v. So that is 6. Therefore, the velocity, the final speed of the object is 6 meters per second. So this is how we can use impulse to find the change in momentum or a change in velocity or the final speed, any one of these, right? So I hope this video was helpful. That's all for this video session. In the next video session, we are going to learn and talk about the thermal physics.